Hello everyone, today in this video we are going to talk about power and electrical energy, and we will derive formula and unit for power and electrical energy. So to understand the power, let us consider a work. I want to shift this block from one place to another place. For that I am hiring two guys. So let's see how do they do the work. So let's see how the first person does the work. So he is doing one at a time. So this is the way he completed the work. So let's see the second person, how does he do the work. Okay, he's doing all the blocks at a time. So from our common sense, as the second guy is taking less time, so we consider him to be more powerful. So let's see mathematically how the second guy is more powerful. So let's see how much work they have done. So they have done the same amount of work. The first person has taken 1 minute, that is 60 seconds to do the same work, and second person has taken only 5 seconds. So in order to give a number to their power, let's divide their work done by time. So for first person it's 80 joules divided by 60 seconds, so it will come 1.33. and if you do the same with the second guy, 80 by 5, you'll get 16. So as you can see, 16 is greater than 1.33. so we can represent power by dividing work done by time. So the number we get is the power. So power is work done per unit time, work done divided by time. So the unit is, so I have to write the unit of work done out here, that is joule, and time is second, so joule per second. So another unit for joule per second is watt. Capital W is the symbol for watt. So watt is the unit of power. Now electrical power of an appliance is energy consumed by an appliance per unit time. So this time we will not talk about the work, we'll say how much an appliance will consume energy in a given time. So as work done and energy is same thing, so we can write, instead of work done we can write energy by time. So for electrical energy I have three formulas, so we'll use the third one. So VIT, energy is VIT by T. So this is coming from Joule's law of heating. So now TT will get cancelled and I'm left with VI. So power is equal to VI. So you can memorize VIP for the formula of power. So now let's see the unit. Now unit is unit of potential difference is volt, and unit of current is ampere. So volt ampere. So again the unit of power is watt, so volt ampere is also watt. So for watt you can write either joule per second or volt ampere. So now let's understand what is 1 watt. So as we know the formula, P is equal to VI. Now I'll put V is equal to 1 and I is equal to 1. If you want to make P is equal to 1, that is power is equal to 1, you have to put V is equal to 1, I is equal to 1. So power is 1 volt into 1 ampere, 1 volt ampere, and volt ampere is watt, so 1 watt. So the power is 1 watt when 1 volt is applied and 1 ampere current flows through the appliance. So let's see. So this is my appliance, this is a cell phone, and I'm applying 1 volt, and if current flowing through the appliance is 1 ampere, then power of this appliance is 1 watt. Power of electrical appliances. So some appliances are powerful, like washing machine. So power of this washing machine is 1500 watt, which means it consumes 1500 joules of energy per second. And some appliances are not that powerful, like electric bulb. So power is 40 watt, which means it consumes 40 joules of energy every second. Electrical energy, the energy which we get from electric current is electrical energy, and we know the formula, power is equal to energy by time, and if you take this time up out here, then you will get energy is equal to power into time. So E is equal to P into T is the formula for electrical energy, and the unit of power is watt and unit of time is second. So watt second is the unit of electrical energy, but this watt second can be simplified into joules. Watt can be written as joule per second, and this is another second. Second get cancelled and you are left with joules. In our daily life we use lot of energy, and 1 joule of energy is very small amount of energy. So in order to buy and sell large amount of energy, we cannot use the unit joules, so we use another unit which is kilowatt hours. This is the unit in which we buy and sell electrical energy. So commercial unit of energy is kilowatt hour, and it is the energy consumed by an appliance of power 1000 watt in 1 hour. Suppose you have a washing machine of power 1 kilowatt or 1000 watt. If you use this for 1 hour, then it will consume the energy 1 kilowatt hour. Now let us convert 1 kilowatt hour into joules. So we know kilo means 1000 and watt means joule per second, and 1 hour means 60 minutes into 60 seconds. So 1 kilowatt hour is 1. For kilo I'll write 1000. For watt I'll write joule per second, and for 1 hour I'll write 60 into 60 seconds. So this second and this second will cancel each other. Then I'm left with 3650 joules. And if you write in power of 10, you'll get 3.6 into 10 to the power 6, because right now decimal point is out here. You move it through 1 2 3 4 5 6 digits, so you'll get 10 to the power 6. So 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joules. Now let's talk about the conversion of electrical energy. So if you want to convert kilowatt hour into joules, you'll multiply with 3.6 into 10 to the power 6. So let's take an example. 5 kilowatt hour is equal to 5 into, you'll multiply with 3.6 into 10 to the power 6. So if you multiply this, leaving the 10 power 6 as it is, you'll get 18 into 10 to the power 6 joules. So if you want to convert joules into kilowatt hour, you'll divide by 3.6 into 10 to the power 6. So this is an example. So 5 joule is equal to 5 divided by 3.6 into 10 to the power 6 kilowatt hour. So I'm dividing. So when you divide this, you will get 5 into 10 to the power, this 10 to the power 6 will go up and it will become 10 to the power minus 6 divided by 3.6. And if you divide 5 by 3.6, you will get 1.38 into 10 to the power minus 6. So 5 joules is equal to 1.3 into 10 to the power minus 6 kilowatt hour. So this is the energy conversion. So you can try this question.